Hey there, champions. Today we've got an application of trigonometry question. It's quite a nice one. It's all about an aeroplane flying towards Melbourne, which would be lovely this time of year. We're given the altitude of the plane, and it doesn't change because it's flying horizontally, so that's a good bit of information to know. We're given the angle of depression at two different points and the time it takes to get between those two different points. So what the actual point of the question is finding the speed of the plane in kilometers per hour correct to one decimal place. So as soon as you see that, you want to think, okay, well, I calculate speed by finding the distance that's traveled by an object or thing and dividing it by the time in which it takes to do it. So for cars, kilometers per hour, runners, meters per second, whatever. So we're given the time it takes to get between 2 points in the question. It's 2 minutes, but we don't know what the distance is between those 2 points. So that's what we've got to use a bit of trig to help us with. So the first thing I'm going to do is draw a bit of a diagram to help me. I'm going to use a right angled triangle. One of the clues for this, by the way, is that it's flying horizontally and it's got what we're given the vertical height as well. So it's a nice right angle drop down to the ground. 400 meters is the height of the plane. That doesn't sound like very much, but it could be enough. I'm not an aviation expert. And at position 1, so at a particular time, I'll just call that position 1, the angle of depression between the plane and the city is 1.5 degrees. Using what I know about alternate angles, that makes this angle 1.5 degrees. I'm just going to sketch that on the right-hand side here for reasons that will perhaps become clear in a moment. So that magenta triangle gives us position 1. Lovely. Now for position 2, so after a couple of minutes, literally 2 minutes, the angle of depression, because the plane's got closer to the city, the angle of depression has increased. It's now a steeper look downwards to look at those lovely city lights. Hopefully the pilot is focusing on his job and not just looking at the lights. So now we've got a new angle of depression of 5 degrees, and because the aeroplane is flying horizontally, we know that the height is also 400 degrees like before. So now what this looks like is that we've got closer to the city of Melbourne, and our angle of depression has increased, but we want to know how far the plane has actually flown so far. So what I can do is if I find the length of the adjacent side in triangle 1, or from position 1, the magenta triangle, and if I subtract the length from position 2, what I can do there is find this length that's here, which is going to be the distance that the plane has traveled. And if I know what the distance is, and if I know the time, I can figure out what the speed is. So because for these two triangles, we're given the opposite and we want to know the adjacent, that means that we're going to be dealing with our friend, the tangent ratio, which is tangent of the angle is equal to the length of the opposite divided by the length of the adjacent. So if I'm finding the length of the adjacent, it means that for position 1, this adjacent length is going to be given by 400 over tan of 1.5 degrees. And for our second triangle, 400 divided by tangent of 5 degrees. Cool, we're getting a lot closer, that's nice. So that tells us that the distance traveled by this plane is going to be the difference between the two. So we want position 1 adjacent, take away position 2 adjacent. That will tell us how far it's traveled. So that'll be 400 over tan of 1.5, subtract 400 divided by tangent of 5 degrees. And what I'm going to do now is that's going to give us the distance in meters, because that's what's given in the question. Melbourne gets a capital late in the game as well. But because in our answer we want kilometers per hour, I want to divide that by 1,000 to convert from meters traveled to kilometers traveled. Now you've got a couple of options here. I'm going to show you my preferred method where we use this expression as our working out. So we're not going to calculate the distance traveled and then round it and then apply it later. What I'm going to do is just use this expression in my next part of the working out. And this is going to avoid any rounding errors. You could figure that out and then leave yourself as many decimal places as you think is necessary to avoid rounding errors, but for me it's just safer to go this way. Anyway, so speed is equal to distance divided by time, as alluded to already. So for my distance, again, I've not written that in kilometers, but I have an expression that represents it. I've got 400 over tangent of 1.5. I want to subtract from that 400 over tangent of 5. I'm dividing by 1,000 to convert to kilometers, and that's going to be over. Okay, so in the question, we're given 2 minutes as the time it takes to travel between those two points. So we're going to have to divide it by 2, but we're going to need to divide that by 60 to convert it from minutes to hours, because we want, circling it for a second time, we want kilometers per hour in our answer. And in your calculator, don't forget to include your brackets for that one as well. That would take me a little while to punch into the calculator, so I'm just going to do a quick spoiler alert and say that's 321.1 kilometers per hour. Worded questions usually get a worded answer, so I'm going to, normally I'd write this, I've probably got enough space to write this underneath. So I'll say, therefore, I mean, it's one note, you could literally keep scrolling down forever. So therefore, the plane is traveling at 321.1 kilometers per hour. Give that a nice highlight to make it clear to your assessor that that is your answer. So you need a few different skills for this question. You need to know a fair bit about trigonometry. You need to know your distance, speed, and time from year 9, I think, ratios and rates and that sort of thing. But the most important thing is being able to identify that this problem needs those skills and then apply those skills to it. It's much more of a problem-solving question than the other things that are on there.